Like a really cool, fun video, so I'm pretty excited to share. And this is about the Cantor Set. I'm sure you're all familiar with what's referred to as Zeno's paradox, which is it like like you have like let's say 1 kilometer, right? Like, and it's Achilles trying to walk that, right? Like actually 1 kilometer might be like too big for what I'm about to have Achilles do. So this is like a retelling of this story. Um, so a reinventing of this story. But yeah, this is 0 and like this is 1. So let's say that like it's like 1 meter, and then like yeah, like Achilles like takes a first step and it's half of this 1 meter length. So his first step is half of this. So then like he would land at 1/2, right? And then now he's got like from 1/2 to 1, so half a length to go, right? Half a meter to go. And what remains, he takes half a step. So he doesn't go all the way to 1, although we're sure he's capable since he was able to go from 0 to 1/2. He can go from 1/2 to 1, but he's going to instead take half a step from 1/2 to 1. So he'd land somewhere like right here. Yeah. Okay, cool. Now of what remains, which is a quarter, he takes half a step. So he's like here, right? And of what remains now, which is an eighth, he takes half a step. So he's right here. And of what remains, a 16th, he takes another half a step. So he's here. And the idea is that if he did this ad infinitum, right? If he did this forever, then we know that this is of length 1/2, and then this is of length a quarter. This here of length eighth. My curvy drawer is like too curvy now. And then this is wait, so half, and then a quarter, and then an eighth, and then a 16th, right? This last guy I drew is a 16th, and 1/32, and so on. Right? And I haven't divided this yet, so what I have is 1/32, but Achilles is going to take half a step of that, so it's going to be adding on 1/64, and so on. So that sum looks like 1/2, 1/2 plus plus 1/4. No, this is not what we're talking about, so bear with me. Plus an eighth plus a 16th, and so on. And if he did it ad infinitum, we just conclude here with a dot dot dot. Why write more terms, right? And we know that this infinite sum is equal to 1, and the visual is supportive of this idea, that if he kept on taking infinitely many half steps, that he'd in theory get to 1, right? And so this infinite sum is 1. Now we're gonna do something similar to this, but using the Cantor set, and it's much cooler. It's still adding infinitely many things to get to 1, but it's like much cooler. So check this out. So this is what just happened? Okay, hold on. I'll live. I'm just trying to erase, and it's not letting me erase. What? Oh, I'm using the wrong tool. What am I on? Sorry. Sorry. There was a sub option in my lasso, and I whatever. You get it. And so let's commence. Let's commence. No. Sorry, it's not me. I swear. Like my tool is acting up now. All right. So again, we begin with a length of 1. So this is 0, and this is 1. But this time, this is what we're gonna do. To start, we're gonna take this interval of length 1 and make an open set of the middle third of this interval of length 1. Notice that this is a closed set, right? It's like in set notation, we'd write 0 and then 1, and these square brackets showing that this is a closed set. And what I'm asking you to do is in your first move of the Cantor set, right? What we're going to do is take this interval from 0 to 1, this closed set, and take out the middle third and make an open interval of the middle third of this length from 0 to 1. We're going to take out the middle third, and make an open interval of it. So then that'd mean I have 1/3, and then what am I writing there? 2/3, right? So I have 1/3, 2/3. So in Cantor Set terms, if we use the letter U, we're gonna say that U11 is equal to the interval 1/3, comma 2/3. So this here is clearly it's this set, right there. Yeah. Okay. Cool. Now we're gonna get what color could I use? I can use white, but let's use red. So we're gonna get that U21, right? U21 is equal to, what is U21 going to equal? Well, we're gonna repeat the process of like taking out the middle third and making an open interval of the remaining closed intervals. So clearly we're not gonna take out the middle third of this because it's an open interval, but we have two closed intervals, one here on this end, so basically the white parts, and then another here. They're both closed intervals, and what we're going to do with them is take out the middle third of each. So we're going to take out this middle third and this first closed interval that we have remaining, and then we're going to do the same in this second closed interval that we have remaining. I'm like using my hand gestures as if you can see. Like, I wish you could see. Well, I mean, I don't care. Like, I'm sure you don't care either. But yeah. Okay. So we take out the middle third there and then the middle third there. And so that's U21 and U22. U21 and U22. Okay, cool. So what is U21? Well, it's a ninth, and then it's going to be 2/9, right? And so a third is 3/9. So we're counting well. And then 2/3 is 6/9. So this here is 7/9. And this here is clearly 8/9. Yeah? Okay, cool. Now, we have then that, well, here, let me just write them. 1/9 and 2/9, right? And then here is 7/9 and 8/9. Now we're going to repeat this again to get us the U3s, right? So it's going to be U31, right? How many of the U3s should I have? U31 definitely, U32, right? And then U33, right? And then U34. Right? Okay. And U3 1 is going to be, unsurprisingly, 1/27, 2/27, which, by the way, notice I could write as 1/3 cubed, and I could have written the 9 as 1/3 squared here, and 7/3 squared. But yeah, 3 cubed, and then maybe it's time to start doing this, and then comma 2/3 cubed, right? And then U32 is going to be what? It's going to be 7/3 cubed, and then 8/3 cubed, right? And then U33 is going to be, well, so U33 would be like, if I do it using green, it would be like that guy, right there. And so we had here, in terms of 27th in the denominator, right? We would say that 2/3 is multiplied by 9, right? So it's 18 27th. So this guy should be 19 27th, and this guy should be 20 27th. So this is 19 27th, or keeping what I said I was going to do. And then 20 3 cubed. And then U34 is this guy right here, right? And this guy right here is going to be what? Well, we just have to subtract this amount right here, like from 1, right? And for the end, and that's going to be like 1 minus 1/27, and so that's 26 over 27. So that's 26 over 27, right? And then, so clearly this guy is 25 over 27, or yeah, 3 cubed. No, whatever, I'll write 27. We'll live. Okay, you see 27, 27 is 3 cubed. Okay, now, one thing to note is like after our first middle third removal, right, or like middle third forming an open interval, we have one one open interval of length a third, right? And then after our second removal, right, like after our second iteration of this process, we have two intervals, each of length a ninth. And after our third, we have four intervals, each of which is of length 1 over 27. So this is important to keep in mind, yeah? Okay, otherwise, if you like really care, there is some pattern to, or there's some method to this madness. If you really care, the U and ones, right? And you can check this for all of them. But yeah, all the U and ones, if you do this like n times, are going to end up being 1 over, this is very anticlimactic, 3 to the n, comma, 2 over 3 to the n, right? Like, for example, the U11 was 1 over 3 to the first, where n is 1, and then 2 over 3 to the first, and then U21 was 1 over 3 to the second, and 2 over 3 to the second, and U31, you get it, you can read. And then the UN2s, right? The UN2s are going to be, what are they? Look at them. They're 7 over 3 to the n, comma, 8 over 3 to the n, right? And also, just to give you one more, the U sub n 2 to the n minus 1. And these guys are always the last guys in each iteration. So like when n is 2, right? Like, and we have to start with n equals 2, because for n equals 1, this doesn't make sense. Well, it gives us U11. It's kind of degenerate. But when n is 2, look at this. This is going to be the U2, comma, what? 2. And so that's this guy. So he's the end guy, like, of the guys that appear left and right. He's the end guy. Not only the end guy, he's the last guy of 2, right? And then when n is 3, we'd get U 3, comma, 2 to the 3 minus 2. So U34. And U34 was our last of the 3s. And so these guys are always the last of the n's. So these are the guys that form at the very end. And so like in the next iteration, it would be like the guy that appears in this middle end if we did it like a fourth time, right? Okay, yeah. Anyway, you get it. And these guys are going to be 1 minus, this shouldn't come as a surprise, 1 minus 2 over 3 to the n, comma, 1 minus 1 over 3 to the n. And I say this shouldn't come as a surprise because, like, let's see. When we figured out that U22 was 7/9 and 8/9, what we did is like, for the 8/9, we saw that like what we had to do is from 1 subtract this amount. Actually, I think we did it for the U34. But yeah, we did it for U34. We saw that what we had to do is like go all the way to 1, but backtrack 1 over 27th. And so that's like go and that's for this tail end, right? So that's like go all the way to 1 and subtract 1 over 3 to the n. The guy on this other that would have appeared on this other end, the our first margin. And yeah, you get it. You get what I'm trying to say. And of course, like for the 25 or 27, what we did is like we took the length of one of the open intervals when we get to the U3s, which is like 1 over 27. That's the length of one of them, right? And we subtracted 1 minus 2 of them because we would have gone like this much to get to this guy, and then the same amount to get to this other end for the 25 over 27. Okay. Now, if you don't get what I was saying here, like maybe like it's worth me like taking the time to re-record this, but or like maybe I could just answer your question in the comments. But that's the only part of this video so far that I'm not yeah, feeling like I might catch everyone on, but hopefully I catch most of you. And yeah, leave me questions if you don't understand. But yeah, like this is the general pattern of how the U sub n's go. And from what I just said, you see that after after one or after our first move, we get an open interval of a length. What is it going to be? It's going to be of a length a third, right? So we get this open interval, and then onto it we add these two guys, and so there's two of them. So I'm gonna write plus sorry guys, plus 2 times, and they're each of length 1/9. They're red guys, right? So 1/9, and then plus, well, these green guys, I didn't finish drawing all of them, the ones on this left end, but there's one there, there's one there. So these guys, they're each of length 1 over 27, but there's 4 of them. So there's 4 of them. So I go, oh yeah, 4 times 1 over 27. And then it's easy to imagine that the next guy is going to be 8 times, or the next guys is going to be 8 times 1 over 81. And so if we like continue in this fashion, right, keep creating these open intervals, then we could exhaust this closed interval from 0 to 1. In other words, we can cover this portion of the number line from 0 to 1. So this segment, we can cover it by doing this ad infinitum. So let's suppose that we did that, which is we covered it by doing this ad infinitum. So then I can go ... and now, well, if you guys need these guys, you could like rewind, right? Just don't let the record skip. No. All right. So here, it was kind of random, but okay. So so here, and so like if we come down here and finish the job, this here is the same as 1/3 plus 2 over 1 over 3 to the first plus 2 over 3 to the second, right? Plus 4 over 3 to the third. And in fact, yeah, like let's continue in this fashion. Plus 8 over 3 to the fourth, right? Plus ... Now, this sum is the same as 2 to the 0 over 3 to the first plus 2 to the first over 3 to the second plus 2 to the second over 3 cubed plus, you get it, 2 to the third over 3 to the fourth plus ... So I have many videos on sigma notation that you ought to check out. But yeah, based on those videos or your own understanding of sigma notation, you should gather that this sum can be written succinctly using sigma notation as being the sum from n equals 1 to infinity of what? Of 2 to the n minus 1 divided by and I don't like that. Divided by, I knew my ruler was close by, divided by what? 3 to the n, right? Okay, cool. All right, so we're almost done because what we have left to do is show that this sum is in fact equal to 1. Well, let's keep the bottom part, which corresponds to our sigma notation in case like we forgot where we came from, right? Okay, but anyway, this is the sum we're trying to find, and from the claim we made at the start of this video, the sum best be 1, right? It better be equal to 1. All right, so here is what I'm going to do. I want to write a 2 to the n here. Well, I can do that if I throw a 1/2 here, and then remove this here, right? Okay, all right. What I had before is the same as this now. Okay, cool. Again, sigma notation videos I've made. we'll educate you on why you could do that if you don't know. Okay, now this is saying one half of what? And I'm sure this is gonna get in the way, so let's take it up here. All right. Okay. Cool. Oh, actually, like right where we want it, right? Okay. Cool. All right. So one half of, well, this is just sigma n equals 1 to infinity of 2/3 to the n. But this is an infinite geometric series, and an infinite geometric series converges to a over 1 minus r, where a is the first term and r is the multiplying factor, the common ratio. I forgot, like, it was called for a second. So 1/2, and so then this infinite sum, as I said, converges to that, where again a is the first term, so that's when n is equal to 1. So that's 2/3 for a, divided by 1 minus the multiplying factor, or the common ratio, is 2/3. So we're multiplying by 2/3 each time in this infinite series, right? So 1 minus r is 2/3, the thing we're multiplying by each time. Okay, so this says 1/2, and again, this better be 1, of 2/3 divided by 1 minus 2/3 is a third. So 2/3 divided by a third is the same thing as 2/3 multiplied by the reciprocal of a third, right? It's 2/3 divided by a third, but dividing by a third is multiplying by its reciprocal. It's the same, right? So we do this. Oh, look at that. Them cancel, and then we've got 1/2 of 2, which is 1. So, as we expected, if we made infinitely many of these open intervals and then added up their lengths, they would have filled up this portion of the number line from 0 to 1. All right, I hope you enjoyed this, and keep watching.